Structured data out there. Top of it that is that when no. More now shifted from metadata layer, from data layer to the metadata layer. And what we see is that the metadata now gets wrapped into many silos.
The other thing that is also making things more complicated is, let's say you have two catalogs, like Unity and Polaris, so Snowflake and Databricks. You want to go just to one catalog and see the updates coming from the other catalog in that catalog. So basically, you would need a synchronization job between those two catalogs. And this is where it's getting super complicated already, right? Because you need to synchronize those two catalogs. And these synchronization jobs, they're very brittle and fragile. Now let's even go further, the ugly one. The AI versus BI divide. And here, you need to distinguish, or you need to understand, like, how is the access pattern for BI workloads? For BI workloads, we are mostly interested in doing aggregations, right? We want to see the monthly sales, or we want to see other KPIs. So here it's very important to have columnar and fast aggregations. Whether for AI and machine learning, it's rather different. So a RAG use case, what you have in a RAG use case is you have random access of certain rows in your table, right? Because you cannot predict. In a vector search, for example, you cannot predict which random rows are going to be the ones that you're actually looking for. So the access patterns are very different. And that's why it's also so hard to come up with a good format that supports both. Iceberg is very close to the Parquet ecosystem, so it's very close to the BI and analytics. But of course, we have more and more AI use cases. Now, what is the result of this is that you need to store your data twice, right? One for the BI use cases in Parquet, and then in maybe Lens or another format for AI. Okay, you can do that, but it's not like very nice from an end user perspective. So I would like to have just one format that can deal with both. Or at least have one abstraction layer then that is deciding, okay, I have only one virtual table, but then two physical implementations. Depending on the access pattern, it picks the right one, right? But we're far away from this. Second one is also the problem of unstructured data in general. So we would like to govern not only the access to our structured or semi-structured data, but also we want to govern the access to our unstructured data. Of course, Iceberg is not addressing this, right? They added variant data type, yes, so semi-structured is covered, but unstructured is ungoverned, uncontrolled, and still something that is a big miss, especially in the AI world, where unstructured data is extremely powerful and important. So actually what I'm looking for is to have the holy grail, that can control structured, semi-structured, unstructured, have an amazing data format for everything, a single control plane. So it's wishful thinking, but I think that's what I would like to see emerge over the years, because I still don't see that we're there yet. And then this is probably the biggest issue that I have currently is we are getting interoperability on the data, but the core problem is that how do we access the data and how is access managed? So in our case, we're an AWS shop in the commercial space. So IAM is the de facto standard for AWS. So yes, we can do fine-grained access control within AWS with Spark, Glue, and now to some extent also Redshift supports IAM now as well. So that kind of works, but then external engines, they don't use AWS IAM, right? Snowflake, Databricks, they use their own role-based access control. So basically what happens is that the security is tied to the compute engine again. And that is a big problem because I don't want to go and define my access model 5 times. I just want to define the access model once in a central place to say, hey, Yannick has access to the sales data and to the customer data, and it doesn't matter what engine he uses, he has access to the data. But today, this is not possible because I need to go into every engine and tell them, okay, he has access to that, to that, to that. So that for me is a nightmare from a data governance perspective. And that's why for me, one of the biggest pain points and the ugliest one is really the data governance as we have it today. So my plea is we not only need an open table format, we also need an open governance format. Yeah, I quickly wrap up here because it's basically what I said before. So I would like to have an open format, open connectivity, and an open access standard where I can define the rules once and then they're enforced constantly by any SQL engine. Also, I want to have a unified metadata layer that understands multiple physical formats, because I acknowledge it might not be possible to have AI and BI workloads in the same data format, but at least give me a unified view that is only like one table in Iceberg, that then whatever query comes and needs to understand what access pattern, give me that. And last but not least, the governance on raw, unstructured data as well. I want to have role-based access control, role level security. And this is even becoming more important in the agentic area, where not only humans are going to access the data, but agents. So to have an agent framework around governance without clear control in one central place, getting very painful and brutal. So really, we need a catalog enforced access control. And this is, of course, we can debate about if this should be responsibility of Iceberg or not. But we need something similar like Iceberg for the open table format. We need for the governance. Yeah, I think I should cover that again. I'll leave with the last sentence here that Iceberg united the compute engines, but the fragmentation simply moved down the stack of either AI file formats or up the stack on the data catalogs and the governance. So that's where we see new wars emerging about the governance and the control of the metadata. That's it.
Guys, do you have like any questions?
I do.
Go
I have many. Well, let's start with probably. Can you give me an understanding of where the iceberg stable sits in terms of like layers? Is it kind of like the bronze or like a silver layer, or you also deal with the data products like for your users?
So basically, the iceberg layer is just the data catalog.
Yeah.
So how you structure then your data within that catalog is totally up to you, right? So if you want to replicate a bronze, silver, gold architecture, you can do that in iceberg perfectly fine, right? So it's basically just a convention on what you consider a bronze or a silver or a gold field. What I was saying before is that with the branching, you might even rethink this architecture. Do you still need it? To what extent? And what should be the data model that goes with it? I think those are more like data architectural decisions that really depend. But if you want to use that the medallion architecture, you can do that in Iceberg. Yeah.
Okay. And the following question, like you mentioned about like a versioning or like a Git-like approach to the data, and I personally didn't work with that. How your CI/CD looks like right now, like from the Iceberg perspective?
I mean, also can be adopted to how you would like to see it, right?
Yeah, but I mean, like in the classical approach, you have like those three environments, like that QA and like production, and also like the replication of the data. Now you may have different states of the data, and you can work from the different environments with the different data environments.
Directly, right?
Yeah.
So you only need, let's say, you only need a production Snowflake cluster,
Exactly.
and then you can have like depth, UAT, and prod in one table because you can branch.
Yeah.
Right? So this is something that you can definitely do with the new branching and time travel capability.
And do you physically replicate the data or?
No, this is the great thing because you really separate the data and the metadata. So if you write new data,
yeah,
you create new physical data, right? So you store it in a Parquet and only the diff. And then you also store only the diff of the metadata. And if then you accept this metadata, you can delete the old Parquet file and the old metadata. Like, I mean, it's a bit oversimplified, but
Wow. I probably like will ask you an additional question and I will shut up. You said it's like you did migration 1.5 years ago. How was it? I mean, how did you do it? Like, what was that approach?
the good thing was for us, we were already on Parquet and on the Glue Data Catalog.
Okay.
I mean, Glue Data Catalog in the old days, I mean, even now still there's migrating now, use the Hive metadata store. That was like the old technology. So moving from Hive metadata store with Parquet to Iceberg is relatively straightforward, I would say.
Perfect. Any other questions? Go ahead.
I'm just trying to dig into what exactly is the problem between the BI and AI stack. Because if I see, for example, you have the schema and data engineering pipeline where you have all the data metadata collection. Do you still want to correlate that somewhere for the AI use cases? Because I'm thinking about one case where you can actually use, for example, PG vector or some other way to have a database where you can have all the embeddings stored, but then you identify some PIDs where you can correlate the data.
The thing you need to think about is in if you have the AI use case, you have let's say you have an identifier and then you have attributes, right? Let's say you want to do a machine learning training model where you need random samples. I don't know if you ever tried to do random sample from a huge table, but this is going against the physics of Parquet because Parquet is columnar. So it's optimized for reading columns. But if you want to read rows, it's not great. It's just by design, right? So that's why I meant for many AI use cases, what you actually want is row level access because you want row 125 because this is the nearest neighbor of row 517 in a vector world, but not in the table, right? They're not neighbors in the table, but in the vector, they're neighbors. So that's where it gets super tricky. because in Parquet, you need to read the full column, and then you can pick those two rows out of it. And if you need to do that 100 times,
Yeah.
it's just not optimal, right?
Just to add to that, because every row group in the Parquet is maybe like 64 MB. And then you want to just read two rows, so you need to read 128 MB. And that's kind of overkill, right? Wonderful. Cool. Yannick, thank you very much. Thank you. I'll take over, and can I get the motion today? Oh, sorry. Perfect. So let me just switch slides. All right. Cool, guys. So I'll talk about Laykeeper, and I will talk about trust infrastructure. So in essence, I usually talk about boring stuff: governance, business continuity management, backup, restore. That is something what we actually build, what this Laykeeper represents. A very short introduction. My name is Victor. If you have afterwards any questions, just connect me on LinkedIn, write me an email. And yeah, and I'm right now a founder of company Vacamo, and Vacamo is the company which actually develops Laykeeper. I want to start with that topic before jumping into Laykeeper or Apache Iceberg in topic of open source, because the reason why we all here is because of Apache Iceberg, which is an open source. And I would love to ask you a couple of questions. So I assume everyone knows what open source is, right? Yes? Cool. Would you please raise your hand if you use your open source, like in your daily work or, you know, any of you? So a couple of you, so usually, yeah, looks good. So now the tricky question, who of you do contribute those? That hurts, right? So the thing is about the open source, it provides, or at least because it has a community. And a community, it means you need to contribute. And contribution is not just about writing code. I understand that, oh, that's kind of a Rust application. I don't know how to write Rust. The contribution means you will just go and read the documentation, find a bug, you will just open the PR, the issue, you can translate, you can try to build a meetup, whatever. So it's all about the contribution. So therefore, guys, just take it hard with you. Think about how you can contribute to open source, because the whole innovation, what we have today, is somehow connected to open source. Speaking of Spark, speaking of Hadoop, Kafka, Flink, Iceberg, so it's all open source projects that actually initiate a huge innovation wave, and therefore think about that. So introducing Laykeeper is open source project. What we started is open source license and Apache 2.0, which means every of you can just go to to GitHub, Laykeeper, and then you will find the Laykeeper, and then you can actually download it and use it, and maybe even contribute to improve it. And that's something what is on our end. So we love open source, and that's why we started actually to develop the Laykeeper catalog as open source solution in the first place. Before jumping into the Iceberg and all the details, maybe just understand on your end, who of you is data engineer? Who is data scientist? No, a couple, yeah, so cool. So, and if I will ask you, who of you would say that your knowledge between 0 and 10 of Iceberg, and 10 is like the expert, like Ryan Drew, would be like a 7? Wow. Okay, so I can talk a lot of shit today, right? So, let me just jump in before talking about the Iceberg and the data evolution, how we actually got to Iceberg and what was like the initial start. And I guess not all of you, but some of you know the data warehouse world of Exadata, Teradata, where we could kind of load our SAP and then build our analytics system and provide to business and data so we can actually make decisions. So that was like 2000, internet happened. And then we got all that semi-structured, unstructured data, clicks, strings, and I don't know, whatever. And the industry understood like, well, it's not really possible to fit that data inside of a Postgres, so we need to reconsider, and that's how Hadoop Vault emerged. And we've got Spark, Hadoop, like Metastore, the catalog of that days, and we somehow were able actually to analyze like maybe petabytes of data. The only one thing that data warehouse and Hadoop, they've been kind of a monolithic type of a system. So the data warehouse was really literally a big box where you have everything on Hadoop side. We said like, okay, let's just make the box smaller, but put it like in parallel and call it massive file processing. But on data warehouse, it was a monolith. Then we get some evolution and we got cloud. And then the companies around cloud started like to build some cloud solutions, and probably the most famous is like Redshift, Snowflake. And there are two cool things about the cloud data warehouse. The first one, it's the easiness of use, of frictionless of use. Click of a button, get the whole cluster, and it runs for you and it's managed by someone. The second thing was cool about the cloud data warehouse. They separated cloud inside of a cloud, compute and storage. And the first time you could actually store petabytes of data, but then you can provision as much as you need on the compute side to run your computation. And it was kind of revolutionary because before that, if you will get a petabyte of data, you need actually to scale your compute as well for petabyte, even if you will run Select 1 on top of the cloud of your data warehouse. So guys, big data said like, oh, we can do that as well. Databricks is probably the main player here. Trino, and I'm going to 340. But the cool part is that what they additionally extended to separation of compute and storage, they separated data. So the first time you got for here that you can actually move from A to B to C. So the data was kind of independent tier. And that was cool. The only one issue was that Parquet is immutable. And you know, like if you want to go and make some delete, update data, it was not possible. Where on a cloud data warehouse, you could do that, but it was hard to scale to exabytes of data, right? So it's why it was kind of like the reality of a lot of companies that they run that in two different paradigms. I have a cloud data warehouse for my analytical data, then I have some kind of data science use case, so let's just go and use maybe some Databricks, or whatever, different kind of systems. And then Ryan Blue, 2017, started to build a project named Apache Icebrook. At that time, it was an internal Netflix project, and we got Icebrook as a dominant file format. We have Delta, we have Hoodie for a while, but right now we have like Lakehouse built on top of Icebrook. And the interesting part, and Yannick was describing that as well, so now we have not only 3 layers, where we have compute, data, and storage. Now we separated the metadata. So we have like 4 different layers right now that we need somehow to manage. So there is a kind of a way more complex situation, because if you take a Postgres, it manages everything for you. You don't need to take care about like the whole internal stuff. Postgres vacuums the data for you, and then you have the governance on top of your Postgres tables and so on. But now you have like all the different layers, and you need somehow to manage. So it's quite challenging. So, but simplifying Lakehouse, only those 3 components what you need to start with. You need storage, you need a catalog or control plane, and you need a compute. That's it. And then you can actually start building the Lakehouse. So this is the most famous art for Icebrook, and if you're inside of the Icebrook meetup and you haven't seen that picture, that's probably on a wrong meetup. But that's like on every meetup you will see the Icebrook structure. And what you can see here, that on top you have a catalog, then you have a meta layer, and you have a data layer. So the data layer, it's a Parquet. Sometimes it's AVO, sometimes it's ORC. Right now we have a new file format API which allows you actually to go and store blends, vortex. So we will probably see more different file formats exactly to address the issue of Gary was talking about the AI, maybe an OLTP use case if I forgot, I don't know, who knows. But the magic is here that we have a meta layer that actually allows us to use the Icebook as a table where we can run a transaction, where we have a schema evolution. So everything what you know from a, let's say, a Postgres table, now you have with Icebook without having a database. There is no database. It's all on storage on S3 or on, I don't know, Google or Azure, whatever you use. So there is no database anymore. The database was actually decomposed in the products. If you look at Postgres, you have storage. Now it's Amazon S3. If you look at the log or uplog, MongoDB, then it's Kafka. If you look at compute, so it's your Trino, your Spark, whatever. And then the last piece was to manage the governance and then kind of like to get that everything, that's the information schema, which is a control plane catalog now. So it's how we started. We started actually to build the catalog, and it was quite messed up. We got all the different catalogs. We got Hive, Metastore, Hadoop, Nessie, JDBC, and you can imagine that every client who was thinking about to write and read from Iceberg, like Spark, Trino, Gremio, you name it, they needed actually to implement all of these different interfaces. And the adoption was slow. Therefore, the community was discussing, and Iceberg community likes to discuss stuff, and they came to the conclusion, oh, let's define a standard. And it's what they have like in mind. So if you look at Iceberg, actually, you have 4 specifications: the table spec, a view spec, the payment spec, and then you have the REST catalog spec. That is actually in place to allow every client just to implement one interface, and then you can use all the different plans. So you're not limited anymore to a single compute. You can just go and use whatever you want. You can write your probably own computer, data fusion nowadays, and use Iceberg. The cool part though is that the metadata JSON file, which is a final commit, is now a competence of the catalog. So the catalog is in charge to get your transaction done. And this is how we started. In 2022, we got a spec catalog, and we started, okay, so it's not just pointing to a metadata JSON file anymore, it's actually in charge to write that file. And now we get kind of a standard that everyone can consume. Then, well, first of all, it was very confusing. Catalog, I have a data hub, I have a relation, I have Calibra. Like, well, it's not the same catalog. And you will see that tech folks and naming is probably not the best kind of like friends. But fortunately for us, 24, everyone started to talk about the Metastore. And it was kind of like natural because we have Hive Metastore. Well, we don't have Hive anymore, we have Metastore. And we added more competency to the catalog as well around the access governance. Now we could somehow manage access to the table and to the view and do some stuff on that one. And now looking in 25 and so on, we actually see that catalogs now playing a very crucial role around the trust. So AI, BI, agentic, all the different players around. So it's all faster and we need somehow to react. So we cannot anymore go to a Confluent page and tick some boxes. It needs to be done on the catalog level. And we see that there is a lot of innovation going around the catalog. Gatekeeper, you can actually take Polaris, you can take Levitino, Unity, Blue, and put it in the middle of that. But the main thing is what you can actually see, that you can use any storages. You can be on-prem with like NetApp for Dell. You can go to Amazon, to Google, to R2, and you can use all the different computes. You're not limited to a single compute anymore. Compute is commodity, and storage is commodity. And that's the cool part, because if you start a project on a lakehouse, you don't need to make a decision today, or would I use Spark, or should I go to Trino, or should I go and use Snowflake, or whatever different of compute. So you're absolutely free. But the cool part of a catalog is they will manage the table lifecycle. So DDL, create table, update tables, drop tables, that is everything done by catalog. In the future, what we see as well, that catalog starting to think about the maintenance of the table to provide you a similar experience what you have on Postgres, where you don't need to think about the table state So you need to run a compaction table, because sometimes you write a smaller parquet files, and you can imagine that if you have a lot of small parquet files, it will just decrease the performance inside of your query range. So you need to run a compaction. You need to run removing orphan files. You need to rewrite your metadata, and so on and so forth. So a lot of different maintenance tasks around the iceberg, and that's something that can be done by the catalog. The second thing is about the fine-grained access control. So now you have a central place where you will put your access control, and that will be then enforced by some of engines, not by all of them. But there are some engines that actually follow that path, and they say like, okay, catalog is in the middle, and we don't want to actually play around with the governance anymore. We just want to concentrate on query execution, and therefore catalog is actually in a best place just to enable that access control. And the final part is about data and AI governance, and that's a different type of a governance. What we have here, it's more like on how to enforce something, which is not about the accessing the data, but enforcing based on the context, what the agent is trying to ask me. Should I just allow to run that query? Should I prohibit that? What about delegation? What about the accountability of that agent who is trying to run the query? And that's like the next additional feature about the catalogs, what we see happening around Lakekeeper, Polaris, and other catalogs. Access governance. So I prepared actually two different demos, what I would love to show you. And first is the access governance. So we have Lakekeeper as a control plane, we have object storage on limit 3. And decision what we made on Lakekeeper side is that the governance is not built inside of the catalog. So we don't want to repeat the experience of query engines and then build that inside of the catalog. We said like the enforcement of a policy can be done inside of the catalog, but the policy itself should live outside of the catalog. And in open source, we deployed the other open source technology, OpenFJ. It's the NCF project, and it's a realization of Google Zanzibar paper that kind of builds ABAC, airbag as a reback, a relational-based access control, which allows you actually to build way more sophisticated things in terms of how to manage that. So what is that actually in our case? So we will just store the tuple object, then the resource and the user privilege here inside of OpenFJ, and that will help us to understand if we can read the data. The thing about the Lakekeeper, it's because it's written in Rust, it's a single binary, you can just easily run that on your Kubernetes service. So it's very helpful. But the other decision on our end was we don't want to be the IDP. So hopefully you have your single IDP, it's your Cognito, your Entro ID, your Okta, your Keycloak, and the identity of a person or of agent lives in that system. And what we will do, we will just use your token and go and make a verification if you steal the real identity, and you can use it in terms of just understand if your authorization fits to that token. The important part of the iceberg, we differentiate between two different computes. A general compute that can be a Spark job that runs a batch job to load data in your medallion architecture, your bronze, your silver, your whatever type of metal you have in your medallion architecture. And it is usually a single user with client ID, client secret that can just go and read and then write to the data. But then we have a trusted compute paradigm, where you have usually not a single user system, you have a multi-user system like Trino, where behind the Trino, you have hundreds of different users, but Trino itself connects with the technical user. And here's exactly the question, like, okay, so should I put the whole role-based access control inside of Trino, or should I put it in somehow for the Lakekeeper in my OpenFGA, and Lakekeeper will just enforce it for me, and Trino will just use whatever mechanism to understand how to treat that Peter can read the data and Anne cannot read the data. So to achieve that, we use another open source technology, Open Policy Agent. And that is exactly how we can leverage the OpenFJ and Lakekeeper tell Trino to allow run the query or to disallow run the query if permission is not allowed. Yeah, but talk is cheap. Show me the code. So let's just go and see how that actually works. Yeah, here we go. First of all, if you want to just repeat the whole stuff, as I said, it's Lakekeeper on a GitHub, and there's a folder examples, and a bunch of examples, and what I will run is the control advanced. And everything what you need to do is actually to clone the repo and Docker compose up, and then you have everything on your laptop. Then if you will install it, you will get the Jupyter Notebook, and then there are a couple of steps with bootstrapping, with creating a warehouse, and then connecting Trino, and then we can run actually the query here. Oh, this is Anna as Peter. So let me just clear the output. So what I want to do right now as a Peter, I want to run the select statement on my namespace finance and products table. And if I will run it, Trino will actually force me to make the authentication. And if I go back, I am able to get the data. All is good. We see that we can get the data. So let's now move to the, in my case, incognito mode to simulate like a different user. In my case, it's going to be Anna. And Anna want to run the same query on the same data. So if we will run it, make the authentication with Anna, Iceberg is password, we will get a permission denied. So this is quite interesting because if you recall, we don't have a single monolith where everything is kind of tight and connected. We have storage on one end, Trino is somewhere else, Lakekeeper is like a different system, then and then that's kind of a challenge inside of a lakehouse to enable the governance so Trino understands how to run it. So what we want to do right now, if Anna will go to Lakekeeper here, sign in, we'll get, well, no access for you, Anna. Let's play a tic-tac-toe here. So what Anna can actually do, can go to Peter and ask him, can you please give me access to that specific table? And here we inside of Lakekeeper, let's go to finance, tables, products, and then permissions, and then we can just grant Anna a select permission, save. Now we have Anna here, and if Anna will repeat now here the same call on this table, will ask me to authenticate again. Now Anna is able to see the data. So just to summarize, Anna itself lives in as identity in a keycloak. The authorization tuple lives in OpenFJ. Lakekeeper manages the tables, and data, Parquet files stored in Amazon S3. All distributed, all beautiful. You can scale all of that components, infinite, and store exabytes of data as Netflix. It sits 1 exabyte of data in their warehouse based on Iceberg. That is possible, but the challenge is how to manage that. So it shouldn't be like a duct tape type of lakehouse, right? So you wanna be very compliant because in almost every industry we have a very strict requirements towards data access, data security. So that's something what you can do. And if Anna will now go to Lakekeeper, check status, now she is able actually to access Lakekeeper. And the cool part, if we go to here, warehouse, we see demo, we see finance, and we see the table products. But if I look here as Peter, I see 2 tables. So which means the whole governance works in that scenario, and it's super easy just to do. So going back to the slides, let me just Get it. So this is actually what you can use it right now, and it's, by the way, all license free. So it's all open source components here, and you don't need to pay anyone anything. You can just run it by yourself inside of your company, and you will get the enterprise-ready solution in terms of how to secure data, how to secure that. And by the way, there are more and more different engines that allows you to do so. Trino, Starburst, Starox, they all allows you to do something like that. But the thing is about the complexity. So a lot of different moving parts, and therefore what we discovered recently, and thank you Amazon Web Services, AWS created a new standard, CEDA policy. And CEDA policy is again open source project that allows you to define your state, your security state upfront through the policy. And that policy file can be very flexible in terms how you want to actually allow access someone. It's not just about the role-based access control. You can use ABAC, attribute-based access control. You will automatically add some attributes to the table, and that will allow you actually just to give access to some entities or to some principles in that case. And the cool part is that it is a declarative approach. And that is something what we call a permissionless code. You will define your permission, you will push that to the Git, then you have a GitHub action with some checks and AI, human in a loop, who will actually approve that change, and it will be moved to the next environment. And like on our side in Lakekeeper, we can just sync that through custom resource in Kubernetes, or it's just a simple file that is going to be added to Lakekeeper, and you don't need to restart anything. But that's the way how you can simplify the architecture, because you don't need two different moving parts. CEDA is just a static file that allows you actually to manage the whole data governance here in that case. The second important topic is the business continuity management. It's sometimes boring, sometimes not. So what is like the current way to insert your data in your Postgres, in your Snowflake, in any system? So you insert your data, you understand you broke something, you're panicking, you're running to your DBA and asking, can we please restore that? Right? So that is very interesting, especially on a Friday afternoon to run some kind of insert and then trying to save it. As Yannick mentioned, we have actually a cool mechanism inside of Iceberg, which allows us to do that with a write, audit, publish paradigm. We don't need to break our data up front. We can actually play with data, we can do some stuff. And let me show you how you can actually achieve that. And it's quite cool what you can actually here do with write, audit, publish. For that purposes, I'm not going to use my local here storage. I will use the Amazon storage, and then you see I don't have any namespace and whatever. So what I want to do now, I will use Spark, and let me just clear out restart and load some data. So right now, just connecting to my cluster here, to Lakekeeper, in order to write data, no namespaces. So the first thing what I want to create is, just increase that a little. So we want to create a namespace and drop tables if we have any, and then create actually the table itself. So let's just run it. And what we're going to do is just add some data to our table. So let's go to Lakekeeper and see here if we got that branching test and we got new table salary. And if I go to the preview, I'm actually able to see my data here as well. So we just have two rows, Bob and Alice, the salary, and that's it. So the next step is, let's just add a little bit more data. So two inserts in that case. We want to add Max and David with a little higher salary, probably from San Francisco, where wages are a little bit bigger. And first I will go to versioning, and you see here exactly how Iceberg is actually created. So every change on Iceberg is a snapshot. And you see that on that snapshot, we've done some different stuff. So we see the fields and but let's just compare the snapshot. So let's just take the first snapshot and let's take the last snapshot, and you see exactly, okay, the first one was actually the override. I will show you the code, and then we appended some data, and you see the sequence, and you see some information about like what exactly happened here. A lot of different metadata, what actually gives you understanding about your iceberg, about this situation. Going to preview. Now we have a time travel option, which means if you want to understand your state of data from last Friday, well, we don't have that many data here, but it's just easy to go to a previous snapshot. And if I go to my first snapshot, I will see exactly those two sentences or two rows. And then I have one row for Max, and then I have a last snapshot here. So that's a snapshot that can be snapshot ID based or time travel based on date that allows you actually to understand how your data evolves. And probably all of you know some B-temporal historization from till whatever. It's a different concept how to manage that. Now, the next step is I want to do some changes. Let's assume it's a Friday and we got the information that some data should be changed. We need to load the data. And before that, I want to create some recovery points, and I will create a branch here in that case. So inside of Iceberg, we have two mechanisms, a branching and tagging, like what you know from a GitHub. So like on a GitHub, you can go and create a branch and then play with a branch without interfering with the main branch. You can create a tag that will actually help you to do some stuff as well. And here, let me just create a branch as well. And if I go back here to versioning, you see that we have audit branch and have a recovery point as a tag here. And the next step is I will load some new data in my audit branch, not in the main branch. And so which means now I'm loading some changes here, inserting new and the salary, and then I do update and just want to change the salary to 70K. So let's just refresh, and this is what we actually got here. So we've got all the different two additional snapshots that are not on the main branch. And if you will go to the preview, and let's assume you run just simple select star from salary, you're not seeing any changes yet. But if we have now the branch and we go to the last snapshot, we will see that data. We see exactly that we added N and we updated both from 60 to 70 right now. So this is now done on audit branch, and if the user is just operating on the main branch, they're all okay. So right now you can do whatever checks you want to do with that. Your great expectation quality check, your HR checks that will tell you, yeah, it's all good. So now we can actually go and merge that. And how are we going to merge this? Action, fast forward to the main. And now that data is available on the main. So let's go to a preview. And on a preview, on a main branch, I have that data suddenly. So that's the way in the situation how we can actually use the write, audit, publish paradigm. And what I want to do right now is, let's say we don't need that audit branch anymore. So let's just delete the audit. And we know that all that snapshots, we don't need them anymore. So let's go and just purge them. So in that situation, I will just delete and expire snapshots. That's one of the steps how you can make the maintenance of your table, because every snapshot means that you have some packet data probably. And you can imagine that if you have many snapshots, you will extend your storage, and storage costs something at the end of the day. So refreshing here, you see that we actually deleted the snapshots that we don't need. And what I want to do here is just right now, well, I'm happy I'm going to a preview, and on the main branch, I will see only now two last snapshots. Let's assume on Monday, when we're done with everything, now we got kind of information, oh, that was actually a mistake, and now we need somehow to restore this thing. So exactly that type of a panicking. But in our case, we can just go and say, oh, I want to roll back to the state of a Friday. And if I go to the preview,
I will get exactly as I started without any reloading. So if you think about like a classical database, how long it can take to reload the whole table from Friday, here is a simple metadata manipulation without a lot of different stuff to do. But again, if you will say, if I need, I can go and restore and redo all that different stuff, but that's something how you can actually play around with Icebook branch and tag mechanism. And the cool part is you don't replicate or you don't copy and you don't need to copy the whole data multiple times because the whole information is inside of a snapshot, which I can show you actually below. That's actually the Icebook. And here you can see exactly the current snapshot ID. You see all the different snapshots, how it's all constructed. And that is how Icebook actually operates without making a copy of the participants. So let me just go back to presentation. Yeah, that is actually it. So just to summarize, Icebook is quite powerful in terms how you can do the data governance. It is powerful in a way how you can actually manage the business continuity without being really in stress if you just did something wrong, because there is an easy way to keep control on your data. That's it from my side, guys. Thank you for your attention. If you have any questions. Go ahead.
How do you see Datakeeper being implemented in the tech stack when you have multi-cloud vendors? Let's say the data stored in AWS, Azure, GCP.
Yeah.
And where exactly you will fit the compute, because I do not want to take the data out of the cloud because that will cost me for the interest if that's a huge data. So how Datakeeper will then interact with compute and where it is hosted?
Yeah, the cool part is that we don't care about the data, we care just about the metadata, and the metadata ingress is not going to kill you, right? So if you will read in some metadata JSON file, we will just retrieve you the information. But on a multi-hybrid cloud approach, it's super easy here. Let me just show you and add here as an example. That take me in a good example where in Ingress, I think doesn't really is a problem. It's R2 from Cloudflare, where you can just add your warehouse. And so it's super easy just to add multiple warehouses from a Lakekeeper site, and you're not going to get like a huge traffic because it's all the metadata. Yes, if you read sometimes Slack from Icebook, you will find messages, oh, our metadata got to 20 terabytes. But yeah, in a usual use case, if you run expire snapshots, you write a metadata compaction, you're not going to get to that stage. And therefore, it's easy just to use Lakekeeper. You will deploy Lakekeeper, let's say, collocate it to your main gravity data, and then you can add all the different here clouds and use it.
And what do you suggest about the identity management? Where exactly, what all integrations are possible with Azure and Azure?
Exactly. So everything what speaks all to that all is good to go. And in that case, you have like almost every usual modern IDP, right? So because I think SAML is not good supported with the Icebook ecosystem itself, but everything what is like here in that case, if you don't want to take the paper, you can just take a cloak, Citadel, and another one from Switzerland, I don't know, is a good solution as well. Perfect. Go ahead.
Yeah, so at first I thought Lakekeeper is the data catalog, or does it communicate? Can it use another data catalog as here you just added another warehouse?
Yeah, so I'm adding storages. Those are not the catalogs at all. So those are really physical object storages that speaks S3 protocol usually. And Lakekeeper is a catalog that manages the, let's show here, you can actually see this. As this is a metadata JSON file that is actually stored by Lakekeeper. We, in our case, we don't just simply store the metadata JSON file. We have a normalized model and a Postgres, and that allows us to be very, very fast. But you will just store, you will create storages, and Lakekeeper will manage Icebook meta.
Okay, so looks super cool. Now I already have my setup based on Glue. I cannot just say, oh, let's switch to Lakehouse tomorrow. Is there a way that to experiment it in parallel with an existing Glue catalog?
Are you using Icebook in Glue?
Yeah.
Yeah. So well, usually let me show you here inside of if you wanna just you can register your tables, because what you need to know is to tell us like how to get there, and then you either can upload the template to the CC, and you have all your tables inside. So it's easy to register because Icebook, that's the default, has a register endpoint, and you can do that.
I have a question related to data replication. Let's say I'm in different regions or with different cloud providers, and then I have users in different regions. Does Lakekeeper somehow help in routing the traffic to the place that the data is the closest to the user? Or this is like out of this picture?
Yeah, so let me go to that one. It's probably the best description in that case. So let's assume you use Snowflake, which is on AWS, and then you have on-prem Trino. And your data is on Google. So all distributed, right? So the architecture nightmare somehow happened. So and now is the question, what Lakekeeper can do? Well, first of all, what we can do, we can open the governed access to those two tools, because your data resides in Google, and your on-prem and Snowflake somehow doesn't understand how to get there, and we can give you like an interface to get. But I don't know if let me just do that maybe. The issue of S3 is Lakekeeper, and is your Trino cluster. It will ask for the meta location of the table, and we will tell S3, and then it runs to S3 directly. So we're not a bottleneck. We don't kind of try to play any role. So which means your Trino, which is on-prem, need to go to S3 through the network, through the ingress, and so on and so forth. So Lakekeeper has nothing to do with the data. It has only the kind of impact on metadata. That's
Basically just saying where to go.
and then gives you a key in that case. So that's kind of the cool part, that in a old ways, you need to have access key and secret key for that second step. Now we have a vendor credentials mechanism that will give you just in time access, and that is a zero trust kind of like a requirement in that case. That means that vendor credential will be off in 1 hour.
What is that one based on? Zero plus one?
You have like different things in a zero trust, and one of them is that your just in case credentials is against the zero trust.
Yeah, I mean, what technology are you using?
Yes.
Can the metadata say that the bucket S3 file is stored in few different places because there is like a replica?
No. But right now, like from the Icebook table specification, you have your Icebook table, and then you have two folders, and then in one lives the metadata. Probably in V4, so Icebook has different versions, and right now we are in version 3, and version 4 will be changed in terms of metadata, but that's always like in one space. And if you think then later on to use Glacier and archive some particular files, it's not possible. Like this today. But it's open source. Everyone can contribute. Cool. Any other questions? Not the case. Then guys, thank you very much. And now we can use like 15 minutes, 20 minutes. Motion.